So we finally get to nitrogen. And the key about nitrogen is on our periodic table. I have a handy periodic table. It's taken me like a full year to realize it's right there for a reason. Nitrogen is going to have, if you go back to when you learned your basic chemistry, nitrogen has 5 electrons. And so it's going to make 3 bonds. It needs 3 bonds to get to be like a noble gas. And it's going to have this unpaired electron there. And that's actually really important. In organic chemistry, with all these things we've been drawing, we never show these lone electrons, but we need to remember they're there because that's going to be, when we get to the second page, the key property of amines. But 3 bonds. They are going to all be single bonds. Although you could have a single and a double, that's not going to be an amine. So we see that like with nitro groups. So we saw that like, and that makes things explosive. So the nitro groups are the nitrogen with a double bonded oxygen and a single bonded oxygen. I did make a video because normally tonight, yeah, when we lost time. So I made a video about some of the carboxylic acids and esters, and then I made a shorter one, I think it was 28 minutes, about the amines and some of the famous amines. So we'll see a little bit on the next page. So those are amines, are going to look like this. The amides, and I think you guys have a picture of yours because I did change that one thing on the notes. The amides we're going to talk about on Wednesday, but the amides, they're going to have the nitrogen. The nitrogen has 3 bonds, but it's going to be attached to a carbon with a double bonded oxygen. So it's looking a lot like an ester, that the esters have that carbon double bonded oxygen and then an oxygen. With the amides, it's going to be to a nitrogen. Right, so this week is all about nitrogen. We're going to focus on amines. I often actually would have done amines sooner, but the snow changed my plans. And then there's a reason this guy's drinking coffee in this corner of this page. I don't know if you made the corner of your first page, but one of the most famous amines probably in our current society is caffeine. That was everything I was going to mention. So I have my space here. Our presentations. So your molecule presentations are going to be, today's the 1st, so either Monday the 8th, which will be 4 to 6. That's what you guys signed up for, and I will confirm that. But there's, I think Haley and Tiara are missing, and I put both of you in the Wednesday group. And so on Wednesday, 3:10, we will 6 to 8 p.m. Yeah. All right, and we'll talk about that more on Wednesday. Monday next week, though, at 6 o'clock, we're going to have a regular class. So that will be the study set, and then we'll be doing a review for the final. And I'll figure out, we'll talk about how to do, there is going to be the study set for amines will be due next Monday. So the snow kind of rearranged our schedule a little bit. The study set that is due this Wednesday is the esters. And then next week on Monday, you'll have the amines, and Wednesday, the amides will be due. All right, so amines. These guys, probably some of the most famous ones are the amino acids. That's where the name comes from, is amino acids are going to have an amine group and a carboxylic acid group. And one of the other key things with amines, why this picture is here, which I'm pretty sure it's on your notes there, is classifying the amines. Actually, I'm not sure it is. And I apologize. Yeah. So classifying amines is going to be a little bit different than when we did with alcohols. But the point of this, and I talked about in the video on the first slide, is that nitrogen is going to make 3 bonds. One of them has to be, the R group is a carbon group. This just means carbons. It could be a methyl group, it could be an ethyl group, it could be a cyclohexyl, it can be any length you want. But you have to have 1 carbon group. You can have 2 carbon groups, they could be the same or different, or you can have 3. So kind of like how we had with ethers, but with ethers you only had 2 things because it was oxygen. With nitrogen, you're going to have 3 things. Also different from ethers is you can have hydrogens, or you can have multiple R groups. So that's just how it is. And so if there are multiple R groups, they will be named alphabetical. And if there's only one, we're going to name these. We're going to go through and we do the naming. This is the common naming way. And we'll also go through the Iupac with these. So isobutyl is isopropyl. So a lot of you get those mixed up. So just be careful. Always take a deep breath. Again, when you're drawing them out, see it as your chance to be meditative. That everything you do in life should be meditative instead of rushing or feeling anxiety and stuff. So isobutyl, we would have that extra elbow, and then we would go to the nitrogen. And the nitrogen is going to have 2 hydrogens. All right, we're going to give it an Iupac name. You have to show the hydrogens. You have to write the hydrogens in that are on nitrogens, just like we did with oxygen. So 1, 2, 3. So we would say it is a 2-methyl, because this is our methyl group. And then 1 propanoic propane amine. Still talking like carboxylic acid. So you do have to put a number. This is the Iupac method. And this is the common. It's more, again, like when we did ketones, that just being familiar with both, because you might see questions either way. All right. Ethyl methylamine.
So on the first one, what happens to the first carbon that's connected to the nitrogen?
That one?
No, because it's a butyl.
So there's 4 carbons, 1, 2, 3, 4.
Okay,
so
maybe I'm just looking at it different.
Isobutyl. So this is the common way. We look at it as it's an amine with an isobutyl group. So it has to do with the perspective of the common way sees it as an amine, and then you have an isobutyl, which has the kink there. The Iupac way says, let's find our longest carbon chain. In the isobutyl, the longest carbon chain is always 3 carbons, and then the 4th carbon is sticking off of it. And so that's why it's a propane with the methyl at number 2. And then they say, oh, by the way, the amine was at number 1. It's more a perspective. And I guess more the thing to realize, Chris, yeah, you're going to see it one way or the other.
Okay. I think that you explained it. It makes more sense now because it just didn't look right at first.
Yeah. Yeah. All right. So my recommendation is you do these kind of like what we did with the ethers. You start with your nitrogen, and then you're going to have an ethyl, so a 2 carbon group, and a methyl, so a 1 carbon group. And the missing bond is hydrogen. So you would show just 1 hydrogen. So going way back since beginning of the term where I said show your hydrogens, this is what I'm talking about. You don't show them on the kinks and stuff. Now, kind of back to the question, just so you see where it's going with the Iupac. And for the small ones, everybody uses the common way. Is how this would be named is for the longest chain is 1, 2. So we would say it's an ethane amine. Now, we don't put a number for ethane amine. for the nitrogen because it has to be at number 1 because it's just ethane. There's only 2 carbons. But we now have to say we have this methyl attached to the nitrogen, and that methyl does not get a number because numbers mean carbons. It gets the letter N, so it would be called N-methyl, and it's a capital N, sorry. N-methyl ethanamine, or acetamine for 2 carbons. And so when we get down here, we'll try with both ways. So Christy, back to your question, this one here is actually the same thing I drew there. If you really want a different perspective, and it's just showing the carbons drawn in, but this is actually the exact same thing as what we just drew there. You can ponder that. It's actually a really good question. And it goes back to what I was talking about, that one of the things that happens with this class is it totally changes how you view things, because it is actually a very visual, organic chemistry is very visual. All right, this one, it doesn't say the word amine, it says aniline or aniline. You can call her whatever you want. That means benzene. The nitrogen is not on the benzene, the nitrogen is attached to the benzene. And right, so that's the aniline, that part. And then we're going to add the side groups. So the ethyl, if the ethyl was on the ring, it would have had a number. It should have, I think I have this named incorrectly. I think it should have said N-ethyl and isopropyl. So if it's on the nitrogen for aniline, it should say that. But if it didn't, just assume that, or you can always ask me. So we would have an ethyl and we would have an isopropyl. It doesn't matter which direction you show it, but there's no hydrogen because the nitrogen's already making 3 bonds. Questions? So we're gonna go back through these 3. So the Iupac way would always show the ends. Yeah, it has to. And I want to go through the categories. This is called a primary amine because it has only one thing attached to the nitrogen. So this is a primary amine. Does anybody want to guess what this middle one is going to be called? Because it has 2 things attached to it.
Secondary?
It is a secondary amine. And then the third one is a tertiary amine. The tertiary amine, there is no hydrogen on that nitrogen. So here's a question to get your name on the board. Why is that going to become important? This is a tough question.
Does that have to do with how it's going to react with other compounds and chemicals?
Actually, it's simpler than the reaction. It goes back to what your question was earlier, Philip.
Oh, polarity and solubility?
Yeah, that guy does an H bond. This one cannot H bond because it doesn't have the NH. So no H bond. So when we get to, I think we look at properties, or yeah, this is the hardest part that the snow did because it kind of made all the study sets wonky, because normally we would have done this today and had the study set on Wednesday and then moved on to amides. So today we should have been on esters, but we'll be fine. It's all good. All right. So let's actually classify the next ones first. Or actually, I'm going to go ahead and pause. I'm going to give you a chance. You can take a break. You can try naming, and you can also try classifying primary, secondary, tertiary. So I'm going to pause it, and yeah, you can take a 10-minute break if you want, or you can try naming. So the nitrogen, the carbon, the nitrogen is attached to does not need to be carbon number 1, but it is in this case. So 1, 2, 3 would be our longest chain. So this would be 1-propanamine. And you drop the E and write amine. And then at number 2, you have methyl. So it's just a different viewpoint, finding the longest chain. Or if you recognize this is the isobutyl, so it is isobutylamine. When you do the common way, you do the YL ending. And so it is just the one that was up there, which is kind of cool. I kept that on there because, so it's a primary. All right, number 2 is, here's our nitrogen. So this side's an ethyl, and that side is a sec-butyl. Sec-butyl alphabetically starts with a B because it is hyphenated. So it's sec-butyl ethyl amine. That would be the common way. Or if we want to go with the Iupac way, we would have 1, 2, 3, 4. So our longest chain is a continuous chain. With the isobutyl, you can't, right? You can't track back. So that's kind of back to the question, Christy, you had been asking. What happened to the 4th one? And I guess this picture shows that with that Pac-Man game, you can't, with the Iupac, retrace your steps. So with this one, you would say it's a 2-butanamine. So the amine does not have to be on number 1. And then we would say we have an N-ethyl. So you're saying the ethyl is attached to the N. This is a secondary. All right. So the next one. So the common way, if you can see the names, do the common way, that's much easier. So that's a methyl, that's an isopropyl, and this is 7 carbons. So this is a heptyl. So alphabetically, heptyl would come first. So we'd say heptyl. Again, they're all YL ending. Isopropyl, methyl, amine. So this is like when we did the ketones, I think it was, they often have 2 ways to name them. And you just have to pick the one, the way that you're most comfortable with. We're also going to name it the Iupac way. And so the Iupac way would be for the longest carbon chain, which is this. So we'd say it's a heptane amine. Again, it's important that that AN is there. And we do want to say it's at number 1 because it is attached to the N. And then we would say we have an N-isopropyl, N-methyl, and then 1 heptanamine. And this is a tertiary because there's 3 things, 3 carbon groups. They can all be the same. So if they were all methyls, we would say trimethylamine, or they can be different. All right, down here, this is not aniline. So why is this not aniline, this one? We didn't get an aniline.
Because
Because it's not a benzene.
phenol.
Somebody, who said the thing about the phenol or something?
That was me. It's Kristen.
What were you saying?
Sorry, just that it's a side group, so it's a phenol.
Yeah, it's at the, I think you're on the right track. The nitrogen is not attached to the benzene ring. I think, Christy, you were saying that too. I heard like both of you, and I didn't know if I got pieces of each. So the nitrogen is not on the benzene ring like it is here. The nitrogen is directly attached, so it's not an aniline. So we would have to name it that this is carbon 1, 2, 3. So we would have to, this one we'd have to name the Iupac way. Oh, I'm sorry, that's a carbon 1, 2, 3, 4. See, I did that on purpose. You guys are all, if we were in person, somebody would have already been like, whoa, what are you doing? So that is actually 4 carbons in a row. So that is the nitrogen, again, does not have to be at carbon number 1. So just like with alcohols, so 2-butanamine. And then this is number 4. Since it is being named as the amine, the nitrogen has to be at the lowest number possible. So that's why the 1 is here. And so the phenyl is at number 4. And it is a YL ending because it's a side group. All right. We would not be able to do this one as a common way. All right. So we have a methyl here, and our longest chain would be 1, 2, 3, 4, 5. So your teacher learned from her mistakes. I don't know how to name my 5 carbon side groups, so I'm not going to do this one as a common way. I think there's like probably 8 or 12 different ways you could arrange 5 carbons. And I know the name of 2 of them, but not this one. So we're going to name it as a 2-pentanamine. And then this is my only piece that did not make part of 2-pentanamine, so N-methyl. So that would actually be at the very beginning. So N-methyl 2-pentanamine. If I'm not going to remember, but I'm going to add a piece to this because this is a question that usually comes up. So what if there was a methyl added there? So I added to our picture. That would be at number 3. So you would actually say N-3 dimethyl. I'm pretty sure the N comes before the 3. It's the phone book thing. Does anybody know they're alphabetizing in the phone book? Do numbers come before letters? So if you said N-3, if you said 3, N, I personally don't care. But somebody out there does. Like your iPhone would care if you alphabetized it wrong, and it would tell you that you did in a very polite way. But that's how you would do it. You actually combine them. The 3, the number means it's at a carbon. The methyl's at a carbon, and the N means the methyl. So you have 2 total methyls. One's attached to nitrogen, and one's attached to carbon number 3. All right, does that make sense? And again, I think it's N-3, but if you wrote 3, N, that's fine. And that actually might be the correct way. All right, let's do one more. So the common way is, this is a Tert-Butyl. And Tert-Butyl does start with a B. So it would be Tert-Butyl cyclohexyl amine. We already did that. I gave so much room for that. And then the Iupac way would just be T-butyl. And then N-T-butyl. So we have to say that the T-butyl is on the N. So N-T-butyl cyclohexane amine. Questions? I'm going to add another piece to it.
So when we do the Iupac form, when we say N, and then for example N-T-butyl, we did the N on the T-butyl because the 4 carbons there's less carbons than the cyclohexane, right?
Yeah, well, yeah, because here, yeah, because the longest chain would only have been 2.
Okay.
Yeah.
Got it. Thank you.
Everybody names that as T-butyl because that's what it looks like. That's a really good question, Philip. I'm going to add one more piece to it, which is, let's make it like that. We'll put it there at that corner of our cyclo. So how would that change our name? Like we could not, if I add that, we would not be able to do the common name because I don't know how to name a cyclohexyl with something extra on it. We'd have to go with the Iupac, and that's an isopropyl. Isopropyl comes after T-butyl, and it would get a number. The nitrogen is going to be at number 1. We just don't say it on a cyclo because that is, for functional groups, are always at number 1 on cyclo. So it'd be a 3-isopropyl. So NT-butyl, 3-isopropyl cyclohexanamine. I changed the question for us. And again, we would not be able to do a common way because this is not a common name. For alphabetizing, it's just the regular alphabetizing rules. So this comes first, not because it has the N, but because butyl comes before iso. All right, we have to put these last 3 into categories. So this one is a primary because the nitrogen has just 1 carbon attached. This one is a secondary because the nitrogen has 2 carbons. And this one's a secondary. So the classification's pretty straightforward. So questions with that? The questions come up with the study set, probably more. All right, we move on. So, oh, boiling point. Insolubility. These guys are a lot like alcohols. So they H bond. Well, primary and secondary is H bond. The tertiary is polar. So again, the tertiary doesn't H bond. So for boiling point, that's kind of where they're going to fall. And then solubility is same like anything. So they are polar. So if you have, let's say, fewer than the 6 carbon rule, that's again a really vague rule, but that's kind of the idea there. So these guys will fall into the H bond or polar. Back to what Philip had asked me earlier. So the nitrogen, let's make it a simple one. So methyl amine. When we're talking about boiling point, it's not by itself. There's billions and quadrillions and Avogadro's number of this molecule. And so you would have a whole bunch of these floating around. And so there's the attraction from one nitrogen to the hydrogen on another nitrogen. And that attraction, that's the H bond. And so boiling point is that we need a higher temperature to overcome. So the boiling point is the temperature to overcome the attraction. To jiggle it apart. So the H bond is just a really extreme polarity. There is more finessing in there because not all H bonds are equal. But for our purposes, it's more important that you see, okay, they can H bond. And then for solubility in water is polar, and so it's going to have that attraction to it. It's just when the carbon part gets too big. All right, the distinguishing quality of these, there's 2. One is they are considered one of the 2 stinkiest groups. So there was a study done, I think it's still ongoing, and it was, they took something called like an e-sniffer or something, and I actually saw a picture of it, and they put different like drops of stuff in there, and they would have people smell it. And so it was done in a way where it wasn't like you're taking a big whiff and knocking yourself out. And they went like different cultures. Like in our class, we have enough different cultures that are there. And there were certain smells that were just offensive to everyone. And there were certain smells that people were like, ooh, I like that. So if we actually were in class, this lab was actually really fun. That you would actually make some esters. The esters are really nice smelling. The esters were the flowers or fruit, so like bananas and apples. The smell of them are esters. And then I had like the essential oils. So the other ones are aldehydes and ketones. When you get enough carbons, they do have a nice smell. Amines are considered the stinkiest, and they smell like old fish. So you have all been in, you've all smelled what fish smells like, or a cat litter box. That is ammonia. So the smell of urine is amines or is nitrogen. And so it is stinky fish. I had a student one year. In my one class, they would do demos. So in my summer class, and this one we were live in person, he said, I want to do the stinky meat demo. And I was looking at him like, are you serious? And so, right, you're live in front of people, and the demo you're doing is to make like this most offensive smell. And he went on for a half hour, and he's making it and passing them around. And anyway, many years later, some of you may have heard me tell a story. Another student of mine who actually we're still really good friends. He is into guns and shooting, and he's at a shooting club. And the guy next to him, he was thinking, "You look really familiar." And he's like, "Yeah, you look really familiar." And they realized they both had been students at Mount Hood, and they finally like narrow it down that they had taken that summer chem class with me. And all of a sudden, my friend's like, "Oh, you're the stinky meat guy." So you don't want to like be remembered for that for your class presentation. The person who did whatever, I don't know. Anyway, so there's stinky fish. The other one, does anybody remember what's the other one that is the most offensive? Nobody's there. Carboxylic acids. Carboxylic acids smell like a locker room, like that hasn't been cleaned, or old sneakers and stuff. So carboxylic acids have a pretty offensive smell. Nobody likes the smell of carboxylic acids. The smelliest of all is cyclohexanol, and I don't know why, but it really is. Anyway, that's the smell of them. Smell is actually really difficult to distinguish when you have the test tubes. It's a last resort, because when you have all the test tubes, they all start smelling the same. Yeah. All right. The key one, though, is I highlighted it, and it was why I was going to take my pink coat off, because now we are talking about bases. That this is something we haven't seen before. The conjugates of the carboxylic acid became bases. So acids turn litmus pink. What are these guys going to do to litmus paper? Maybe I'm not still here.
Turn it blue.
Yeah, it's going to turn litmus blue. Thank you for answering. I got worried that I froze, and it occurred to me, we were in our prayer group this past weekend, and Joey in our screen like suddenly froze, because you can see, because everybody else freezes, and that's when you realize, oh, it's me who's lost my Wi-Fi. And I just realized if I lost my Wi-Fi, I wouldn't know it, because none of you are on. And so I would just see black boxes. I would just keep talking for like another hour and then find out, oh, but hopefully it recorded. So it's going to turns litmus blue. So acids turn litmus pink, and bases turn litmus blue. And was something that Kristen asked last week, which is that you actually, there's two different colors of litmus paper. So does anybody know what litmus is? See, at Chem 104, you should. It's a natural thing that's actually abundant here in the Pacific Northwest. Starts with an Li. It's a lichen that grows on trees and stuff. And anyway, so you can either get pink litmus paper. It's like a pinkish purplish color. And if you dip it into a base, it turns into a blue, like the lighter blue. Sorry, I'm always mirrored and I never know. Yeah, the color of this pen. All right. Nothing else that we've dealt with is basic. The exception is the carboxylic acids when they become their conjugate base, but pretty much all the other families that we dealt with for the first 7 weeks were all neutral. So the reaction is if we just take methylamine, which is a methyl and the nitrogen. So this is the base. And we add HCl, which is the acid. That the acid is going to give its hydrogen up to the base. So the base accepts the hydrogen. And the reason it can do that, does anybody know why this one can do this? Remember that picture I drew of nitrogen? It had those two lone pairs. Those two lone pairs of electrons, that is where the hydrogen gets attracted to. So what you end up with is CH3, NH3, and it's now going to have a positive charge because it picked up an extra hydrogen. And then the Cl is going to be Cl with a negative, and that is what an ammonium salt is. So the name of this would be methyl ammonium chloride. And I can tell that it's been years since I've had a full 10-week term, because I used to have a whole nother page, but this is usually the part of the lecture that gets squished out. Yeah, so we talked about salts before. So what are some of the properties? Or what are
They
some properties?
ionic.
They are ionic. So what does that mean, Melanie?
They have a positive and a negative charge to them.
I know, but in terms of properties.
That they are completely water soluble. Like they just
Yes.
keep going and going.
Anybody else? What else about it?
They are a solid.
They're going to be a solid, yeah, which means that they have a long shelf life. What else?
They have the highest boiling point.
They do. These will have the highest boiling point. I have to start writing on the board. I'm not going to remember. Maybe there's one more big property change, or two actually. Anybody else? They are now weak acids. Because they've gained that extra hydrogen. So we go from a base, and this is going to be called, remember, the conjugate acid. And then the other big property is they have no smell. They're salt. They're a solid ionic compound. They're going to smell like your salt shaker pretty much. Well, maybe not. Ammonium salts might have a smell. I'd have to think about that. They're not going to have this smell anymore. All right. So a lot of drugs are nitrogen compounds. And the drugs, and those of you, so I know Vincent is talking about one of these, I'm pretty sure. The drugs are actually the salt, because it gives them the shelf life and stuff. And so on the sheet, how they would name this is methylamine hydrogen chloride. So they actually just they show it like this, but the name that they give is methylamine hydrogen chloride or something like that. But it is that they put it into the ionic form because it makes it soluble in our body, and a bunch other properties and stuff. All right. So we're going to walk through some compounds. These are all amines. No, they're not. One is not. Actually, this one is not either. So caffeine, so somebody did pick caffeine. Amines show up. So the term alkaloid, does anybody know what the term alkaloid means? Did anybody watch my video? Probably not. Alkaloid means it's a plant compound. That's okay. That was, yeah. It's less painful this way because none of you watch it and I don't know. And when we were live in class, I'd watch people look like they were in pain having to sit there for 30 minutes watching me talk. So black boxes, I don't have to see the pain. So it's a plant compound with nitrogen. And they are usually poisons. And they usually have a bitter taste. So the taste bitter is actually telling us it was a warning sign, like you shouldn't have this. It's a poison. And that's why a lot of plants develop alkaloids so that animals, birds, insects wouldn't eat them. We as humans, there's something like 200 different bitter taste buds. And that's why some people don't like cilantro. And then some people like me, I absolutely love cilantro. I have no issues with it, but some people, because our taste buds are different, 50% of people actually taste cilantro tastes like soap to them. And so they absolutely will not eat anything with cilantro in. So some of you, depending on your ethnicity and stuff. So I mentioned once that my aunt says that we originally came from Spain or somewhere. So I'm probably distant cousin with a lot of you, but thankfully. Asians also seem to do okay with cilantro because we eat a lot of cilantro in our house. So caffeine, these are nitrogens. These are amines over here. But I wanted to point out these other nitrogens are not. These other nitrogens are amides. So does anybody see why those are amides? We haven't, this is where our topic will be on Thursday. We're almost done, if anybody's still there. The nitrogen that the carbon is attached to has a double bonded oxygen. And so these are called heterocyclic. Well, they have purines and all that name. Anyway, we're going to talk about amides. Amides are neutral. The pH thing, once you get that carbon, the oxygen there, it changes. So they have no impact on pH. Oxytocin, I think somebody picked oxytocin, am I right? Maybe not. Wow. That was the other thing I wanted to mention. That's the purpose of this pictures here. I do hope sometime between, well, you don't have that much to do Wednesday, that you start looking into your compound, but definitely by the weekend, you can absolutely switch. You just have to have a clear communication with me. But oxytocin is, I talk about in one of my videos, that it is the molecule of love, is what it's known as. It's a polypeptide, so it's 8 amino acids hooked up together. And a lot of these are actually amides because it's hard to see, it's a little blurry. That's an amide because the nitrogen, the carbon it's attached to is a double bonded oxygen. I'm trying to find the amine group and I always have trouble on this one. I don't know why I'm not finding it. Oh well. Anyway, oxytocin is an amazing molecule. So if you don't like yours, there's lots of them. Nicotine was picked. I have a theory that one of the anatomy teachers must have done a talk on nicotine because nobody's picked nicotine for like 20 years. But these are amine groups. And so I do have a question about these amine groups. What category? Primary, secondary, or tertiary? So let's do this one first.
Is that one tertiary?
That one is tertiary because, so it's interesting because it's part of a ring. So again, it's called a heterocyclic ring, and that nitrogen is attached to a carbon on each side and one below. So it is a tertiary. You can also tell it's a tertiary because tertiaries do not have what?
Hydrogen.
Hydrogen on the nitrogen. Yeah, who said that?
It was Kristen.
Oh, okay. I don't know why, Kristen, your name never pops up. So yeah, there's no hydrogen on the nitrogen. So this is a tertiary amine too. And so that double bond within the ring would make it a tertiary. This one is not because we see the hydrogen, so it can hydrogen bond. So this one over here is a secondary amine. These would be, this is a catechol. So these are phenols or a catechol. So epinephrine is also known as adrenaline. Dopamine is almost the same molecule because it's made from epinephrine, or vice versa. I have to think too hard for that. And so dopamine was picked, but not epinephrine. Down here, this is capsaicin, and I can't remember how to spell it. That's why I stopped there. This is not an amine. So one more time, why is that not an amine? Or does anybody see? That carbon, so this is an amide. So the carbon the nitrogen is attached to has a double bonded oxygen. What is this group down here?
Is it an ether?
That is. I was going to say Caitlin should for her ether egg. You're the only one who did that. You're the one who did the ether egg for the end of your flow chart. That made me giggle. I don't know why. This is a phenol. And then that, of course, would be an alkene. Are we going to try and name this? I don't even know how you would name it. Yeah, that's actually really fun when you guys do your presentation. So I know I keep joking saying nobody watches my things. So I made those videos so that we would be done a half hour early each class. I do talk about your presentation in there. So even if you just watch the first 10 minutes of it. So I did the molecule anandamide, and then I talk about 2 studies in there. So for your presentation, I'll talk about this again on Wednesday, if anybody's still listening. You do need 2 studies, and you should talk about them. They definitely need to be in your paper also, but that is something you should start looking into to make sure, oh yeah, I'm going to find some studies. But you can change your topic on Sunday even, and some of you are going to be doing your presentations next Wednesday. But sometimes people have trouble finding some good studies to talk about, or studies that are interesting or that they can understand, or they find information on something else. So we just need to make sure to communicate about that. But you need to make sure that you have pictures. This is a chemistry class, and so we want to talk about the chemistry. You have to have a picture of your molecule. You're probably going to have a picture of your molecule more than once. And then it's really fun because this will get to be Kaylee's thing, is you will be able to find what the name of this molecule is, and it will take up like the whole slide writing out the name. You don't have to read the name to us, but some of them, it's not on this page. So like morphine, I know somebody's doing morphine. Morphine and heroin have really similar, or like Caitlin's doing another opioid that you'll probably want to also have a slide. And same with caffeine, that's not an opioid, but there are other molecules that have similar structure. And so having a slide where you sometimes show some of those similarities, and that we can look at and see that. And just a reminder, right, to be conversational and being able to talk to us, and having the eye contact, it turns out, is even more important in this environment. The last one I wanted to talk about, so this is actually an amino acid. So in an amino acid, this position here, the place, the carbon that the amino group is on, so my little dot there, I have the amino, it also has the carboxylic acid group. And then this part is different, but the amino acids are, so this is an amino acid. That they also, in our body, they are always ions. They are drawn incorrectly almost everywhere. It's really hard to find a picture where they are drawn correctly. So they usually show this as an NH2, so they wanted, everybody's afraid to show it as an ion, but our body is water-based, so that would make sense. Once it forms into the peptide, which becomes an amide, we don't have the ions anymore. Yeah, so it's never too late to change your topic. Well, I guess after you do your presentation it is. And I think that's all I got, unless there's a question. We're gonna do amides on Wednesday. We have a study set due Wednesday and a worksheet, and I'll be here at 5, like always, and I will stay after. I'm gonna stop.